Good morning. Today we are going to see the problems that is on variable acceleration. If we will go to the last videos, then we have solved problems on constant acceleration and motion under gravity, that is special case for constant acceleration having value g equal to 9.81 meter per second square downward. Now, to see more videos on engineering mechanics, you have to go to Civil Engineers Technical Hub YouTube channel. In that, you go to playlist, and in engineering mechanics, you will go over there. Then you will see around 18 to 20 videos are there which are related with your engineering mechanics. Now, some of them are listed over here which are related with our SPPU University, and question papers are solved over there. Now you can see this already mentioned. We are with basic concept, equation of motion we have covered, motion under gravity, and now we are going to be with variable acceleration. Motion curves we are not using, we are going to be with derivation, and from this we are going to solve this. So now we have first problem asked in 2023. I think you just go through question paper and then you have to solve it. Now, before going to this, so I will go with concept of this. So I will be here only. What is difference between position, distance, and displacement? Try to understand these three terms and displacement. Now, whatever we have position, so suppose I will say we have this as origin. At t equal to 0, so I will write here t is equal to 0, we have s equal to 5 meters. So we have s, so we have 0 over here. So let us 5 somewhere here. We have 1, 2, 3, 4, and 5. So here we have when t is equal to 0. Now at t is equal to 3 seconds, let us, we have something s equal to 20. So now I will go directly 5, 10, 15, and then we have 20 over here. Now this 20, this is position. Position of the particle is 20, means position is always referred with origin. Is always referred with origin. Now second we have displacement. Already we have seen what is displacement? Shortest distance between initial and final position. So we have this as initial position, we have this as final position. And then we have this as 5 and this as 20. So what will be this distance? So we have this distance is 15 meters. So I have displacement 15 meters. Then what is distance? This is path traced by the particle. So we have to start it from initial and we have to move it, and it will be till 15. So we have again same 15 meter. So when we have these two same, so if motion is unidirectional, if motion is unidirectional, unidirectional means it is in the same direction, unidirectional, then we have distance and displacement are same. So then when we have this different, so now I will consider another example. So let us, we have, this will be my origin. So let we have, this will be 1, we have this will be 2, we have this will be 3, we have 4, then we have 5. Here we have -1. Here we have -2. Now we have at t is equal to 0. Sorry, I will write here t is equal to 0. We have s equal to 2. So this is position. Now let us I have t is equal to 2. We have s equal to 5 and t is equal to 4. We have s equal to -2. And we have to study only between t is equal to 0 to t is equal to 4 seconds. And we have to find position, distance and displacement at t is equal to 4 seconds. So now first we have position, which will be referred with origin. And with origin, what is position at t is equal to 4? It is -2. So we have -2 meters. Now what is displacement? Distance between initial and final position. Now initial we have t is equal to 0. So this is initial position. And here we have t is equal to 4. This is my final position. And then we have distance between initial and final position. Now we have here and then we have here. Now while finding displacement, we are with sign. So now you can see where we are going. We are going towards left. Then what will be my displacement? So this will be -2 and then -2. So my displacement will be -4 meter. While finding displacement, initial position considered as origin, and then we have to see final position is towards left or toward right, as we have seen in motion under gravity. And then what is distance covered? Now distance cover, we have to start from t is equal to 0. So we have to trace the path. So t is equal to 0, it will go till 5. So distance covered in this direction, this becomes your value, that is 3 meters, because 2 to 5, 3 meters. And then it will go back. So now we are saying distance, so it is not being with any sign. So we have this distance, how much? So from 0 to this 5, and then it is 2, so total 7. So what will be distance traveled? Path trace means I have to go from here to here. So 2 to 5, 3, and again I have to go from 5 to 2. So it will be 7 plus 3, and distance covered in 4 seconds, and that is equal to 10 meters. So we should be able to know these position, displacement and distance. If it is in one direction, here in first we have seen our motion is only in one direction. But here particle will go till 5 meter, and then after 5 it start to move in opposite direction. And therefore we are going to be with this. Now you may say how it is possible. So now you can see, if we will take V is equal to 2 minus 2t, then at t is equal to 0, we have plus 2 meter per second. At t is equal to 1, our value of v is 0, means value is decreasing. And then at t is equal to 2, your particle means at t is equal to 1.1, its velocity becomes negative and it will start to move towards negative direction. At t is equal to 2, you have -2 meter per second. Means it started to move in opposite direction. So it will go to 5, its value becomes 0, and then it will go towards left. So likewise, we have concept of position, distance and displacement. Now we will go with the problem. So now I already mentioned we cannot use. So we have three equations. V equal to U plus AT. We have V square plus U square plus 2AS. And S equal to UT plus half AT square. These equation we can use when A is constant. Now is A constant? No, because we have A equal to T by 6. And therefore we cannot use these equations. Can't use these equations because these are applicable only when A equal to constant. And now we will go A equal to T by 6. So we know what is A. So we have A equal to dV by dt equal to T by 6. Rearrange the terms, we will get 6 dV equal to T dt. Now integrate on both sides. So we have 6 dV that is equal to integration T dt. Now integrate it. So we have 6V equal to T square by 2 plus C1 I will say. Now given, what is given? Where A is acceleration and time t second initially, then t is equal to 0, the velocity is 2 meters per second. The data is given, this you have to write at start. T is equal to 0, V equal to 2 meter per second, and S1 I will say initial displacement 7 meters at T is equal to 0. And this plays very, very important role to find constant of integration. So we have at T is equal to 0, V equal to 6. So 6 into 2 is equal to 0 plus C1, and therefore we will get C1 is equal to 12. Now we have to determine velocity and displacement when, so we have to find that T is equal to 3 seconds, and therefore we will get that is 6V we have equal to T square by 2 plus C1. Now we have C1 value as 12. So 6V equal to T square by 2 plus 12. And now put T is equal to 3 seconds. And then we will get 6V equal to 3 square upon 2 plus 12. And from this we will get 6V equal to, this is 9 by 2, 4.5 plus 12. And then from this we will get V equal to 16.5 upon 6. And it comes 6 2s are 12. Then we have 4, 6 7s are 42, 3, 6 5s are, so meter per second. So at T is equal to 3 seconds, velocity is 2.75. So write in the examination in this fashion. So examiner need not require to check your answer where you have this answer. Now I have to find displacement. So I have to use equation of V. So we have equation of V, 6V equal to, so we have 6V equal to T square by 2 plus 12. Now again I will write 6V we have ds upon dt, and that is equal to T square by 2 plus 12. Now rearrange the terms. So we have 6 ds which is equal to T square by 2 plus 12. Now integrate on both sides. 6 ds equal to integration T square by 2 plus 12. And then by integrating, we have 6s equal to T cube upon 6 plus 12T now plus C2. Now given at T is equal to 0, we have S equal to 7 meter. So I have mentioned S1, and therefore we have 42 equal to C2, and therefore C2 equal to 42. Now we will put this in the equation of displacement. So we have 6s equal to T cube upon 6 plus 12T, and this is plus 42. Now put t is equal to 3 seconds. Then we have 6s equal to 3 cube upon 6 plus 12 into 3 plus 42. And then if we will solve this, so we have value of s equal to, I will just calculate it. First we have 27 by 6. So it comes 4.5 plus 36 plus 42 and it comes 82.5. So we have 6s equal to 82.5 and therefore we have s equal to 13.75 meter. So write answer properly. So you can make the box for the answers. And then we have this will be at t is equal to 3 seconds. So in this way, we have to solve the problem, that is displacement and velocity. Now we will go to the next. This is, I think, from 2022. So the car, or 23, we have question 6. So the car moves in a straight line such that for a short time its velocity is defined by. So we have given velocity v, that is equal to. So we have v is equal to 3t square plus 2t, where t is in second. Determine its position and acceleration when t is equal to 3. Now initially is given t is equal to 0, s equal to 0. Now if we will put value of t is equal to 0, then you will get v also equal to 0. So now we are interested to find acceleration and position. So now first we will go acceleration. We know a equal to dv by dt. And we have rate of change of velocity. So 6t plus 2. So when derivative, no constant will be there. And from this I will get a equal to 6 into 3 plus 2. And we have this value of v. Sorry, value of a. We have 6 3s are 18 plus 2, 20 meters per second. So we have this value, that is at t is equal to 3 seconds. So see, in all problems they are using 3 seconds. So that 3 is my favorite of this examiner. So we have a equal to 20 meter per second square at t is equal to 3 seconds. And then we have to find position. Now see, we have to check it. Is velocity is going to become negative? So no question, because t is equal to 0. So we have v equal to 0 only at t is equal to 0. And after this, we have velocity as positive, and therefore we have position, we have displacement, we have distance, all are same because it start from origin. Means in this problem, my position, my distance, and my displacement, all three are same. Now why? Because at it start from origin, and therefore if it start from origin, then we have these values will be same if motion is unidirectional, and here my motion is unidirectional motion, because velocity never becomes positive because we have all terms are positive, and at t is equal to 0, v is 0. Now we will have this v equal to ds upon dt, and that is equal to 3 square plus 2t. Now rearrange the terms. We have ds equal to 3t square plus 2t into dt. Then integrate both sides. So we have ds equal to integration 3t square plus 2t into dt. And from this we will get s equal to 3t cube upon 3, 2t square upon 2 plus c. Then 3 cancel, 2 cancel. And we have at t is equal to 0, s equal to 0, and therefore C equal to 0. And therefore equation of S is T cube plus T square. And from this, we will get equal to 3 cube plus 3 square. And then S equal to 27 plus 9, and that is 36 meter, which is position. So we have S equal to T equal to 3 seconds. You can write here position, and in above, you can write acceleration. So we have this as acceleration. Now we have last problem. The acceleration of a particle is given 3a equal to 3t square plus 2. Initial velocity is given t is equal to 0. V is 2 meter per second, and S1 we have 3 meters. And we have to find position, velocity, and acceleration at t is equal to 2 seconds. So here we have 2 seconds. So now we have first acceleration. So A at t is equal to 2 seconds. And then we have A equal to 3 into 2 square plus 2. So we have 2 2s are 4, 3s are 12. So A is 14 meter per second square. And that value we have at t is equal to 2 seconds. Then we will go for velocity. So we have A is equal to dv by dt is equal to 3 square plus 2. Then from this we will get dv is equal to 3 square plus 2 into dt. Then you integrate it. So we have integration dv is equal to integration 3t square plus 2 into dt. Now integrate it. So we have v is equal to 3t cube by 3 plus 2t plus c1. Now this 3 cancelled, and we have therefore v is equal to t cube plus 2t plus c1. Then we have at t is equal to 0, v equal to 2 meters per second, and therefore we will get c1 is equal to 2. And now we have to find at t is equal to 2 seconds, we have v is equal to 2 cube plus 2 into 2 plus 2. And then we have v equal to 8 plus 4 plus 2. And we have value of v, this is 2 cube. So 2 cube we have 8 plus 4 plus 2, and this becomes 14 meter per second. And therefore we have v equal to 14 meter per second, that is velocity at t is equal to 2 seconds. And then we have to find position. Now here also you can see what is equation of velocity. So we have, I will go to the next slide, v equal to t cube plus 2t, and we have plus 2. Again we have motion as unidirectional. Then we will get all values are same. Position, velocity, and position, distance, and displacement. Now we have ds upon dt equal to t cube plus 2t plus 2. Then you rearrange the terms. So we have t cube plus 2t plus 2 into dt. Then you integrate it. ds equal to integration t cube plus 2t plus 2 into dt. And then you integrate it. We have s equal to t4 upon 4 plus 2t square upon 2 plus 2t plus c2. Now at t is equal to 0, we have value of s. What is given s? S1 is given 3 meter. You can see at initial position, they have mentioned over here 3 meters initial. And then we have we have to see at t is equal to 0, then we have s equal to s is not 0, so our position will not be same, so we will get it as s equal to 2 meters. And now we have this actually gives you now position s equal to, now we have to find that t is equal to 2 seconds. Our equation of s is t4 upon 4 plus t square plus 2t and plus 2. And now put it, so we will get it as 2 to the power 4 upon 4 plus 2 square plus 2 into 2 plus 2. And then we can have this as 2 2s are 4, 16. So we have 4 plus 4 plus 4 plus 2. So 16 plus 2, 18 meter. So what is, now you try to understand it. I will explain it. So now we have 0 over here. Now at t is equal to 2, my particle is at this point 2 meters. T is equal to 0. And now at t is equal to 2 seconds, particle is at 18 meters. So our position is 18 meter. But what is distance or displacement? So distance or displacement unidirectional, and therefore distance and displacement are same. As it is not from origin, so all three are not same. I mention it, but it is not same. But in unidirectional, it is always your distance and displacement same. Distance and displacement same. Then when position is same, if it start from origin, and this is not starting from origin, and therefore we have position and distance displacement are little different. So now we will stop here only. Remaining part we will see in the next lecture. So if you are not subscribed, subscribe Civil Engineers Technical Hub. So thank you.